So we can characterize the groups of the periodic table with specific electron configurations. For example, the first two columns of the periodic table can be referred to as the S block. And this section of the periodic tables can be classified as the P block elements because they all have their final electrons in the P sublevels. And the first two column elements have their final electrons in the S sublevel. And then this is known as the D block. And then this is known as, I didn't include the inner transitions, but we don't have them anyway in this problem, so we're good. The first column elements, like hydrogen, lithium, these alkali metals, they all have electron configurations that end in S1. Right, and ns just refers to the principal quantum number, the energy level. All right, so just show you real quick. Hydrogen has an electron configuration of 1s1. It only has one electron. The next one down is lithium, has an electron configuration of 1s2, 2s1. And then sodium will have 1s2, 2s2, 2p6, and 3s1. And so I'm just going to highlight, there's the 1s1s. They all end in 1s1. Right, so the answer to A is going to be your alkali metals. Wait, what is the question? List the symbols. Well, they're right here. All of those are going to be your answer. H, Li, Na, K, Rb, Cs, and Fr. Those are, we'll just call the group 1, or your alkali metals. Your elements that end in the P block, so I'll go back to green here, P4, those are going to be the fourth column in the P block. And because the P sublevel can hold 6 electrons, they're represented by the 6 columns in this P block. All right, so if all these elements would end in P1, all of these elements would have electron configurations that end in P2, all of these would have electron configurations that end in P3, all these would have electron P4. So that's going to be our answer. And by the way, you can keep going P5 and P6. P sublevels can hold up to 6 electrons. All right, so our answer is the oxygen group. You can also know it's by the number of valence electrons. All of those have 6 valence electrons, so that's group 16. It's going to be the answer to part B. Group 16. Elements are all going to have their outermost principal quantum number S is going to be full, and then the P's are going to fill up to number 4. All right, so for oxygen, for example, is going to have electron configuration of 2s2, 2p4, all right, and then the core electrons I didn't write. Now sulfur is going to have electron configuration of 3s2, 3p4, right? That's sulfur, that's oxygen, and so on. They're all going to have this P4 that characterizes all those elements. And then let's go on to the D block here. All right, elements at D orbitals can hold 10 electrons. So to have 10, it's going to be in the last column of that D section. So all of these electrons, all these elements are going to, I'm not going to go that way because there are some exceptions here. These are going to, if the S's are full, which are, hold on now. So this is the 3s, and this will be the 3d. They kind of stagger, right? Because of alpha-bal. All right, anyway, all of these here are going to end in D10. So that's zinc, cadmium, mercury, and then this periodic is old, but that there is something there. I don't really know what it is. Yeah, I'm not going to try. So Zn, Cd, Hg, and whatever 112 is, those are going to be the answers. And that would be in the old, sorry, I just sneezed. So in the old periodic tables, it's called group 2b, or the newer ones usually group 12. All right, anyway, the zinc group is fine. Let's go with group 12.